So in our notes, I'll bring the notes back up just to show you that all these formulas are in the notes. In the notes, I say, scroll down, we still get 0 over 0, so we define the new thing, and here's a picture, and then, there it is. Okay, so there we go. We have y minus f of a equals limit h goes to 0, f of a plus h minus f of a over h, all over x minus a. All times x minus a, and that is the second version, and that's what I call it. This is the second version of the definition. All right? So we have a first version and a second version. So let's do the same problem we just did. Using the second definition, or second version, we're looking at y equals 3x squared minus x plus 1, if I'm not mistaken, that was it. And we are looking at the point 1, 2. Right? That was it? 1, 3? Yeah, because I can't do simple math. It's okay. 1, 3. Okay, find the equation of the tangent line for this curve at the point 1, 3 using the second version. So we, again, still know that this is a. We still know that this is f of a, right? But let's see how this formula changes. Limit h goes to 0. Instead, f of a plus h minus f of a all over h times x minus a. So there's the formula, the second version. And let's plug stuff in. Y minus, do we know f of a? It's 3. Okay, equals limit h is going to go to 0. Now be careful on this next piece. Do you know what f of a plus h is? You don't. It's not 3, right? F of a is 3. But f of a plus h you don't know. So watch how I write this. I'm going to write f of, what is a? No, what is a? 1. A is 1. So isn't that really 1 plus h? Isn't that what that is? Because a is 1. So f of a plus h would be f of 1 plus h. And then minus, do we know f of a? 3. And then over h. That's our limit that we're going to do, and then times x minus 1. So I replaced that a with 1. I replaced that a with 1. I replaced f of a with 3, and I replaced f of a with 3. And that's my new setup. You all hanging in there? Okay. Let's go do that limit. The limit as h approaches 0 of, all right, now we get to actually figure out what f of 1 plus h is. You're given the f function, aren't you? It's that parabola. And if you're told to plug 1 plus h into it, that means you're going to replace all your x's with 1 plus h's, right? So it becomes, this top left corner becomes 3 times 1 plus h squared minus, in parentheses, 1 plus h plus 1. That is just this piece right here. That is this, right? What do we still need next to that? Minus 3. And then all of that over h. Now I can, yes?
So what you did there was you just replaced the x.
I replaced the x in our function with a plus h, which in our case is 1 plus h because a was 1. Right? So this is 1 plus h. 1 plus h went there, and I had to put this in parentheses because the negative had to go through to both.
Why?
Why does the negative have to go through?
Why are we replacing with that?
Why? Because this general formula says this will work with any function. You give me a function, and this is what you have to compute, right? And that's the function that was given to us in this problem. So if I change this, this changes, right? Any other questions? Now you get to figure out, go ahead.
Where's that plus one came from?
This plus 1?
Yeah.
Right there.
Oh, okay.
Right?
Okay. Right. Oh, okay.
You sure? Okay. Now, we get to do some algebra here. Like, yes, we have to expand this out. 1 plus h times itself. Then distribute a 3 through. Distribute the negative through. Collect all of our like terms together. Cancel things when we have to, and let's see what we get. All right? Limit, h goes to 0. Notice the limit, I'm writing it every time because I'm not taking the limit yet. All right, so on the side here, what would that 1 plus h squared be if I do 1 plus h times itself?
1 plus 2h plus 1.
So it's 1, so I still have a 3 out front, don't I? 3, and then when I do that, it's 1 plus 2h plus h squared. Is that what you said? Right? That's what would happen if you FOIL this out and then collect like terms.
Yeah.
We cool with that?
Yeah.
All right, now what do I still have next to that? How about this? Here and here. So minus 1 minus h, and I still have plus 1 minus 3. So minus 1 minus h plus 1 minus 3, right? All of this over h. Now the 3 gets to go. So we get limit h goes to 0, 3 plus 6h plus 3h squared minus 1 minus h plus 1 minus 3. I could have put these together, but I'm just going to leave them for now. All over h. I'll put them all together on the next line. Combine like terms in the numerator. Still have a limit. Limit h goes to 0. All right.
3h squared.
3h squared. So yeah, you want to put it in descending order? You don't have to, but I'll do it. 3h squared on, that's this guy, right? So I've taken care of this.
5h.
Yeah, so if I do 6h, take away an h, that's 5 h's.
And then plus 1. That's it. Because negative 1 plus 1.
This, everything cancels, right? All the constants cancel, so all you get is that. And then all of this divided by
Divided by
h.
h.
Now, let me tell you something. You know how in the previous way we did this with the other formula, what we were trying to get was a factor on top and bottom to cancel? When you use this formula instead, you're always trying to get this h to cancel. And that means your answer up here better have h's in every term, because you need to be able to factor an h out, which I can here. I can pull an h out of the top. That's just greatest common factor out of the top, right? H comes out, and then now bam, bam, like that. And then we will do the limit as h goes to 0 of 3h plus 5, and that's just 5. And wasn't that what we got earlier? I would argue that this method, this second version, was a little more challenging, a little more work. Wouldn't you agree? I think the first version was better for this one than the second version.
How do we know which version?
You don't. You don't really know which one to use. Most people just decide that they're going to marry one of them. They just say, I'm married to this one, and that's the one I'm going to go with.
Similar to completing the square versus quadratic formula? Kind of take one?
Yeah, I would say yes, only that those are major different approaches. Like completing the square versus quadratic formula are completely different like operations you do. These are very similar. It's just that your limits start looking different. The way you plug things in is a little different. But yes, there are two ways to get to the same point. What do y'all think? Now I'm going to stop here. We weren't done, right? We could then go get the equation. That was just the slope. Right? We'd have to go y minus 3 equals 5 times x minus 1. Okay. How are we doing on time? We have more notes. So here's the summary. If you're given a function, given a curve, y equals f of x, then the equation of the tangent line at the point AF of A, that base point, is either this limit, or sorry, is either this equation or this equation. The main differences between the two equations are the limit. In this limit, x is going to A, and that's the difference quotient you're going to use. And then in this one, h is going to 0, and you're going to use this one, provided the limits exist. Now, we haven't run into any problems yet, so we won't worry about it. So those are the two, basically you could say these are the two formulas we have for the slope of the line, right? Yeah. Those are the two formulas. Now, these are so widely used, okay? This computation is so widely used and utilized in other things we're going to do that it actually has a very special name, and it is called the derivative. Okay? So I told you this is about the derivative, right? We are now defining the derivative of a function at the number a to be either one of those limits. You choose. But they both mean the derivative of the function at a. And we use a special notation. This is the notation we use right there. It's f with the prime, that we call that the prime symbol, f prime of a. It's the way you say that. The derivative of f at a, or you could say f prime of a. So let's say I give you this function, f of x equals x squared. Then if I say what's f prime of 3, right? What I'm saying is, what is the slope of the tangent line, right? If you go out to 3 on the x-axis, go up to the point, what's the slope of that tangent line? That's what that's saying, right? F prime of 3 is the slope of the tangent line. Only the slope, though. It's not the equation of the line, right? It's just the slope of the line. But that is the derivative of the function at 3, which you could, we could go through that, but I'm not going to. Now, some things that, some language and some consequences of this derivative. F prime of a, right, is referred to as the instantaneous rate of change of the function. This is, I've already said this, right? This is how I introduced it. But just to be clear, the derivative, f prime of a, not only represents slope of the tangent line of a curve, it also represents the instantaneous rate of change of the function. So, just repeating myself, but it's here in the notes, so you've got it. Now, this is kind of interesting, but again, this is something we've talked about. If you're looking at some function where it's giving you what's called linear displacement. So if you have an object moving in a straight line, and you have a function that tells you exactly where that object is at every point in time, then the derivative, f prime of a, is the velocity, is the instantaneous velocity of the object at that point in time. Again, this goes back to the picture I drew where I think in the beginning of this class I said, like, you're driving to school. Did I say something like that? No? You're driving, drew a picture? No? Okay, never mind. If you have time here and distance here, then this is a position function. And therefore, the slope of the tangent line represents the velocity of your object at an instant in time. And that's pretty much it for 2.1. All right? That's pretty much it. Let me see what these other examples look like. We're not done, okay? Don't be all, yay, we get to go home early. Because we need some more practice. Yeah, let's do that. Let's do that. Okay. If y equals x to the negative 4, find this. So I'm asking you to find the derivative of this function at 2. Tell me how fast this function is changing. What's the instantaneous rate of change of this function when your x-coordinate is 2 on this function? All right, so all we're looking for is the slope, right? This is not asking for the equation. All we have to compute here is that limit. So we're using either this formula or we're going to use this formula. One or the other, right? Yes?
What about the x minus a on the side where you multiply it?
What about it?
Wasn't there like another?
No. Okay, so we're trying to find f prime of 2, right? F prime is just the limit part.
Oh, it's not.
It's just the slope. That's all it is. I'm not asking for the equation of the line. That would require more work. So this is actually easier work because all you're doing is finding that limit. That's all you're doing. Are we clear? Yeah. Okay. So let's try and find the, which one do y'all want to use? Any, mini, miny, mo? Yeah? You want to use this one? Yeah. All right, let's do it. All right, so remember in this formula that x is never going to be changed. The only thing you can replace here is the a. All right, so if I replace the a, what am I going to replace a with here if I'm doing that problem? 2, right? So this is going to be limit x approaches 2, right? F of x minus, f of 2? Is that okay if I put that like that? F of 2 over x minus 2. That's just me rewriting this formula, replacing all a's with 2's. And I knew a was 2 because, well, that's exactly what they said, right? Yeah. All right. Now we're not done. We have to kind of see what we can do with this. I'm not ready to take a limit yet. I got too much crap in here. I don't know what it is. Do we know what f of x is? Do we know the function? It's that, right? Okay, do you all agree that that's 1 over x to the 4th? That's x to the negative 4? Okay, so that's x to the negative 4, and then minus what? F of 2. That means that's what I get when I plug 2 into the function, right? Now, in the past problems, wasn't I giving you the points 1, 3, and like this was a and this was f of a? So like I gave you f of a? But see here, I'm not. I'm just giving you 2, which means you've got to go figure out what f of a is. But that's kind of easy to do, right? Just plug 2 into the function. So what would happen if I plug 2 into there? What's 2 to the 4th power? 2 times 2 times 2 times 2? 16? 1/16? Over? The whole thing over? Whole thing over? X minus 2. That's strange. Who just came in? Who just walked in? Okay. You got some sort of like electromagnetic field around you or something, messing with the electronics. All right. We clear on this? Sure? Now, if we checked real quick, as x goes to 2, this would become 1/16. Minus 1/16, 0. 2 minus 2, 0. We have 0 over 0. Yeah, so how do we do this one? Algebra, right? Algebra. And when you see fractions like this with other fraction, like big fraction with little fractions, you want to try and get common denominator. No conjugate. Don't think conjugate because you don't see roots, right? So I need to get a common denominator. I need to put these two together. Now, assuming that you can do that, and that might be too much of an assumption, but multiply 16, 16 here, x to the 4th here. So that's what I'm doing, and then I'm putting them together. Now, if you need help on that step, we get together some other time to talk about that, but not right now. Okay, so I put these two together. That's this, and then it's still over x minus 2. Now remember, we're trying to get the x minus 2 to cancel, aren't we? But I don't see an x minus 2. Does anybody recognize what 16 minus x to the fourth is? What do we call that? 16 minus x to the fourth. I'm going to write it down over here just so we can look at it for a second. That is a difference of squares, isn't it? That's 4 plus x squared, 4 minus x squared, right? Now this is not a difference of squares. This is a sum of squares, and there's no formula for that. This one is, there's a formula for that though. This is what? Splits again, doesn't it? Another difference of squares. 2 minus x, 2 plus x, right? Well, that's nice because I think we're going to be able to cancel. Let's just keep going here. I'm going to erase this. So here's what we've got. We've got this equals limit x approaches 2. This whole top up here became 4 plus x squared, 2 minus x, 2 plus x, all over 16x to the fourth, but then all of that over x minus 2. Y'all still alive? Yeah, so what you need to see here is that this is a big fraction over another fraction. This is like over 1. And so anything that's up here can cancel with anything that's up here. Do you all see that these are almost exactly the same? But they're not the same. They're off by a sign, aren't they? So I'm just going to be real clever here. I'm going to pull a -1 out, like that. And that will change that. I always feel like when I'm teaching this and like I'm up here doing this that students really don't understand what I'm doing at this step.
Well, technically, if you rewrite it, it's negative x plus 2, so you're pulling out the -1, so you change the sign and make it x minus 2, so you can cancel it.
So it'll be the same as this, right? But I think students don't understand, like, if I put a negative out here, like why that negative doesn't impact these two, like why it only impacts this one. I think students struggle with that. So I'm going to do this a little different, just for the sake of trying something different. If I multiply this by -1 and the bottom by -1, would that be fair? If I do that top one and that one by -1 on top and bottom, would that be the same thing? Yes? Now what happens if I multiply the -1 through to this one? What would happen? Take this and distribute the -1 through. What would you get? Minus and then plus, right? And then this is no longer here. Now, don't these match? Right? Don't these match? Okay, so I can cancel this and this. And so what I'm left with, be careful, is this times -1. So I'm going to write that as -4 plus x squared and then 2 plus x. And then all over what? 16x to the fourth. And everything else is canceled, hasn't it? Everything else is gone. And that should be it. We canceled the bad piece, didn't we? The bad piece got canceled. So now we should be able to let x go to 2. So no more limit. Negative. Okay, plug 2 in here. 4, right? 4 plus 4 is 8. -8. 2 in here. 2 plus 2 is 4. Times 4 over. 2 in here. 2 times 2 times 2 times 2, right? 16. 16 times 16. 16 squared. So the top is, yeah, I'm just wondering if we should have just reduced earlier, but -32. I could have reduced it. I can reduce it at the end, doesn't matter. What's 16 squared?
Why not just,
No?
16 squared is 256.
256.
But I mean, couldn't you have just reduced everything by 4?
Yes, I could have reduced earlier.
8 by 2 and then turn that 16 into a 4 and then take 4 squared?
You could have done a lot of different things, actually, yes. Just got to be careful that this 16 is really, you can't do like 1 and 2 here because it's being squared. You can't do that. You just have to be careful, but this is it, right? Reduce it, who cares? Yes? That's the slope of the tangent line. That's f prime, this is f prime of 2.
Do you care if it's in its absolute reduced form?
I don't care. Now, my 9-year-old daughter, she'd be mad if I didn't reduce that, but. Okay, what do you think?
It's algebra.
It's algebra, yeah.
I still don't get why you didn't distribute the negative one to the middle. But I can ask it later.
Why I didn't distribute it?
Yeah, it's okay.
Well, yeah, we can talk about that later. All right, now, we used this formula, didn't we? Wonder if this one would have been any easier. Let's see. I'm gonna see if I can sell you on the other one maybe now. I don't know. So I'm gonna go very quickly through this, okay? This next one, because we already have the answer, but I'm now gonna use that formula instead. So f prime of 2, watch me, limit h goes to 0, f of a plus h, but a is 2, f of 2 plus h, okay, minus f of 2, right? F of 2, didn't we say that was 1/16?
Right.
Over h. That's it right there, right? That's me using this formula instead of the other one. Now, f of 2 plus h means I need to plug 2 plus h in right here. So this becomes limit h goes to 0, 1 over 2 plus h to the 4th power minus 1/16 all over h, like that. So remember, 2 plus h into that function is really 1 over x to the 4th. So if I replace x with 2 plus h, I get this. This is already starting to look pretty bad. Common denominator again, right? Like, if I let h go to 0, this is 1/16 minus 1/16, that's 0 over 0. So I'm going to try and put these together right now, which means I need a common denominator. So I have to multiply 16 on top and bottom here, so I get 16, minus I have to multiply 2 plus h to the 4th on top and bottom there. So that's going to be 2 plus h to the 4th right there. And then over the common denominator, 16 times 2 plus h to the 4th, then all of that over h. So this is common denominator on those two. Unfortunately, I need an h to cancel, right? And it can only cancel with something up here. So I need to multiply that out. 2 plus h times 2 plus h times 2 plus h 4 times. Right? I have to do 2 plus h times 2 plus h times 2 plus h times 2 plus h. Sorry?
When you go higher than squared, but you're staying with even exponents, are you able to do the same trick as you are with squared?
No, I'll show you a way you can do it later. I'll show you a kind of a shortcut. All right, so I'm going to do these two and these two, like those, and then I'll put them all together. So if I do these together, I get 4 plus 4h plus h squared. Trust me on that? Same thing here, 4 plus 4h plus h squared. So then I have to multiply those together. So when I do that, got to go here to here, here to here, here to here. Those 3 multiplications, and then here to here, here to here, here to here. Those 3 multiplications, and then here to there, here to there, here to there. So I'm going to have a total of 9 multiplications to do, and then I'm going to collect all my like terms. Okay, I'm doing it. 4 times 4, 16. Okay, 4 times 4h, 16h. 4 times h squared, 4h squared. Plus, now we move to this. 4h times 4, 16h. All right, 4h times 4h, 16h squared. 4h times h squared is 4h cubed. Almost there. Last one. 4h squared, 4h cubed, h to the 4th. Okay, that's this, right? That's this. Let me collect them together. Okay. Okay, I'm going to go this order. 16, that takes care of that. How about h's? How many h's do I have? 32? How many h squareds do I have? 24? How many h cubes? 8. And finally, h to the 4th. Okay. That's life, right? That's the way it goes. We're not done. Keep going. So now back to the limit. I need to take the limit as h goes to 0 of 16 minus this, right? So that means each of those gets a minus sign. Minus 16 minus 32h minus 24h squared minus 8h cubed minus h to the 4th, all over the common denominator, 16 times 2 plus h to the 4th, all over h. And you see something good happens up on top?
So on the top, where's the...
Those go.
You, but I was going to say, I would have written 4H, I would have factored out 4H. Or are they, can you factor 4H?
You can't factor 4h, not until you got to cancel these 16s first. And that's good because once you cancel those 16s, do you see everything up there has an h? And now you can factor an h out, or 4h, whatever. I'm going to pull just an h out of the top. If I pull an h out, I haven't sold you on this one, have I? I'll give you an example next class where you'll basically have to buy into this one. But like I said, you marry the one you want, okay? I'm not here to tell you which one to love, all right? Gone? Now, at this stage, finally, you can let h go to 0. And if h goes to 0, what happens? Gone, 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 right? Yeah. And so all you're left with is negative 32 on top. And on the bottom, that's gone. So this is 2 to the 4th, which is 16, and that's 16. So that's 16 squared. And that's the exact same answer we just got. Whew. All right. Isaac Newton had too much time on his hands, didn't he? Let's just start this over. How are y'all feeling about this? Make sure you do your homework, okay? Because that's the only way you're going to get used to this sort of algebra. I have 10 minutes, I have 8 minutes, so that gives me enough time to show you something really cool. Let's see if you follow this or not. How many of you remember this from college algebra? First of all, that's a parabola. Yes, that's all parabola. And all parabolas either open up or down, right? And this point right here had a special name. It was called the vertex, right? That point right there? Called the vertex. And there was a formula for it. They told you that to find the x-coordinate, we didn't call it x in college algebra, we called it h. Do you remember that? HK? Called this point HK. And they told you that h was always going to be negative b over 2a. That all you had to do was take that number, change its sign, divide by 2 times that number, and that would give you the x-coordinate of the vertex. Does that sound familiar? Yeah. Okay. Check this out. Check this out. Watch me now. I would like to know what f prime of a is. Okay? Remember, that represents the slope of the tangent line at a, right? Slope of tangent line at a. So if I look at this, you know what? I don't want you to confuse this a, this b, this c with that a. So I'm going to use an arbitrary number. I'm going to use b instead. All right, instead of a, because I don't. No, sorry, got to use something completely different. How about t? Okay. F prime of t. This would mean limit as h goes to 0. I get to choose. I'm going to go f of x minus f of t over x minus t. So all I've done is just written the formula out that we just had a second ago. I replaced all my a's with t's. With me? Okay, now.
Why did you do h goes to 0?
Yeah, I shouldn't have done that. Thank you for catching that. It's x goes to t. Thank you. I wanted to use the other formula is what happened. Shoot, I don't know if I'm going to have enough time. Let's keep going. Limit x goes to t. Now, shit, I'm not going to have enough time. I'm not going to have enough time. So why don't I cheat a little bit? Why don't I cheat? Because I still want you to see this. Why don't I cheat? Remember how I showed you that little shortcut a second ago? I said, you can't use this yet? Yeah. Okay, let's try that little shortcut real quick. If I do that, this is an x to the 0 here, right? So I bring this down, right? So if I wanted to know the derivative of this, I'd bring this down. I have 2ax, right? And then this is a 1, so I bring that down, I get what? Plus b, and then x to the 0, right? And then this one, the 0 would come down. That's all that would be left. This expression right here tells you the slope of the tangent line, doesn't it? Now, when you're looking at a parabola, either in that case or in this case, what would the slope of the tangent line be if you're at the vertex? What's the slope of the tangent line if you're talking about the vertex on a parabola? What's that slope? Horizontal line has a slope of what? I heard it, 0. Okay? Horizontal lines, the slope is 0. 0 slope, positive slope, negative slope, right? So if I'm sitting here and I'm going, hey, how can I ever find the vertex of a parabola? Then I really just want to know where the derivative is 0, right? So what happens if I set this equal to 0 and solve for x? What do I get? Solve for x. Where's that derivative 0?
Negative b over 2a.
Negative b over 2a. Right? Just move b over and then divide by 2a. And so it tells you that if you are looking at a general parabola and you would like to know where the slope of the tangent line is 0, then you need to move to where your x-coordinate is negative b over 2a, and then you will have found the x-coordinate of that point. And see, with a parabola, there's only one place that happens, right? There's only one place on a parabola where this happens. The more profound question is, what if you have a function that does something like that? Right? And in college algebra and every class you've taken up to this, you've never actually gone and tried to find these points, have you? No. You've never gone after them, trying to find the highest and lowest points, but we can. Because we're going to take the derivatives of whatever function it is. We're going to take the derivative and we're going to set it equal to 0, and we're going to be able to find these. Because it'll tell us everywhere where our tangent lines are 0. Does that make sense? So this derivative is going to allow us to find what we call maximums and minimums of general functions. All right, I'm out of time, I think. Yeah, that's close enough. Do your homework for 2-1. I'll see you on Thursday, Valentine's Day, right? Is that right or no? Is it? What would you rather do on Valentine's Day than calculus? I mean, you got to do what you love.